Excited to have you all here. I'm John Efeoglu, product manager on the Lakehouse Federation and Databricks SQL teams. I'm joined here today by Todd, Greenstein, and Angeli, who are product management and one of our engineering leads on working on a project. I hope this morning's keynote from Mate was exciting for you all. I'm so glad to have a lot of Lakehouse Federation features being featured in that keynote, right? A lot of exciting stuff coming up across the board. So we kind of wanted to give you an overview of some of the things we've done in the past year, including some of the things that Mate announced, and also give you a look at like what we're thinking for the next year and how that kind of plays in with our larger strategy, and how that's going to plug in with a lot of the other stuff you heard at Databricks, right? The AI BI dashboards, AI BI Genie, Unity Catalog, and all of these awesome announcements. I'm required to say this, right? Any of the stuff that I'm showing you guys might change without notice, but we'll try to make sure that we hit the roadmap as it happens. Before getting into a deep dive on the actual, content, I just wanted to kind of level set of why we're doing this in the first place. When I talk to customers, right, they have data across many different silos, right? Whether that's databases, whether multiple data lakes, whether that's like multiple like data warehouses, right? Data is scattered, whether it was like a legacy issue, whether it was something where your marketing team is using this database, but your IT is using something else, right? There are many reasons for it, but in no organization that I've ever talked to at Databricks, they have everything in a single place. And what this causes is complexity, right? So you have these data lakes, you have these warehouses, you have these databases, which all come with there are different formats, there are different ways to access them, different JDBC drivers, different like APIs, right? On top of that, as you kind of are trying to manage them, especially on the data lake side, right? There's no really single solution to manage catalog. So you end up having a high meta store, you end up having Databricks Unity Catalog, you might be using something else on the AWS or Azure ecosystems. So you have many kind of ways of managing the metadata as well. And on top of that, right, you have to govern them all separately. Right, so you have permission sets on one database, on one DW, on this data lake, on different catalogs. And whenever you're trying to access it from your compute platform, you're in this pickle of like having to kind of manage all of this complexity on your own without really having a centralized view or anything where kind of gives you an easy one-point access. And that's honestly the main problem we're solving at Lakehouse Federation, right? We're giving you a single point of access to manage all your data and access all your data and have a view, a catalog view of all of your data. So we started with databases and data warehouses, right? You just heard earlier today that we're GAing, a lot of our connectors, like all the Synapse, Azure SQL Server, Redshift, MySQL, Snowflake, Postgres, and a lot more coming in the pipeline. And we're also focusing now a lot on the catalog federation aspect of the question too, right? Bringing in High Metastore, Apache High Metastore, AWS Glue, and kind of presenting all under the umbrella of Unity Catalog through a single interface. And why are we doing this? Just to kind of go a bit deeper, right? Is one, we want to give you a catalog of all the things in your ecosystem, right? Not just whatever is in your Databricks environment, but like in your AWS ecosystem, in your Azure ecosystem, in your Google ecosystem. And on top of that, we want to give you access, not only catalog, but access to all of that. So you want to be able to use that in your machine learning, in your data science, in your pipelines, and have access to all of this without having to ingest first, right? We're basically giving you a way to have all of this metadata being mirrored, if I were to call that, on Unity Catalog, and on demand accessing it, and you can ingest it when you need it. You can real-time query it when you need it, or you can basically, have it ready for whatever future use case you're going to have without having to commit to it up front. And on top of that, right, with all the capabilities of Unity Catalog, you can actually govern all of that centrally too. So all of the things that you heard us announce for Unity Catalog in terms of, catalog integrations, permissioning, lineage integration, insights, role levels, fine-grained security, later on, ABAC, that will all be inherited through these external data sources. So you could kind of have a layer to put additional governance on top of that. And one thing that's, and Mate kind of hinted at this was actually my slide originally, but is basically, this has taken off in terms of how fast people are picking up and how deeply they're integrated into their ecosystems, right? What you're seeing on the right side is how many queries per day we're seeing just from federated data sources. And this is actually not even including the High or the Glue meta store. This is just databases and data warehouses. And this basically corresponds to, just north of 5,000 active monthly users. And, one of our close partners as, customer partners on this is, for example, using Lakehouse Federation, Shell in this case, to basically be able to have multiple environments they're managing throughout migrations very smoothly without actually having to, fall over to anything else or like having to disrupt the customer's use cases. So let's actually start and deep dive on the database and DW Federation side and kind of give you a quick recap of like everything that we've been working on. Just to kind of level set on how these things work and how they're getting used to them is we basically introduced a few different concepts in Unity Catalog to make sure that you can manage your credentials, you can manage your metadata, and you can manage permissions on top of these data sources. So one of those things is what we're calling the connection object. So you basically can just go to Unity Catalog UI or APIs if you want, or SQL, select from this list of like whatever database you want to connect to or whatever data system you want to connect to, and just enter your credentials, and Unity Catalog will manage that access on top of it. And then that basically gives you a secure way of managing credential and connectivity centrally in Unity Catalog, and then give access to different folks in your organizations, whether data engineers, whether they're analysts, or you name one. And on top of that, right, we basically allow for you to create what we're calling foreign catalogs to mirror the metadata of these underlying connections and systems, right? Think about your Snowflake environment, think about your MySQL environment, or think about your SQL Server environment. As you create a catalog, external catalog, using these connections, we go ahead, fetch all the relevant metadata that is available in that system, make it available to you in the catalog browser, make it available in your information schema, make it available to BI tools, ETL tools, whatever you name it, just as if they were internal tables. And what that means is that you can now go and literally select star from Unity Catalog.schema.MySQL table, and we will actually go and figure out the right path to query that database, just like you were querying any other Unity Catalog table. And that's through the foreign catalog capabilities. And on top of that, when that query is happening, let's say you're joining your MySQL with a streaming Delta table, with something on your Snowflake environment, with something elsewhere. You're smart enough to look at your Databricks SQL query, figure out what filters you have, figure out what joins you have, figure out what aggregations you have, put through our query optimizer, and get you to have better performance by pushing down compute to those target systems without you having to do anything. So the system is smart enough to figure out, for example, hey, I have this filter and this aggregation, and I want to just retrieve these columns from my MySQL table, and that will actually translate your query into the target system's dialect and push that down. So you only get the results that you need without having to ingest or transfer a lot of the data. And this happens, by the way, per system, external system, right? So all of that is happening transparently without you having to do anything in your system. You're basically just writing Databricks SQL, and we're doing all that work behind the scenes for you. And and sometimes, right, you might have a large table. You might be doing like a demo like Andrew is going to show you later on, where you're basically doing like a 8-way join between a streaming table, Snowflake, us, a bunch of these different systems, which may not be really fast because you're dealing with just the physics of it, which is like a lot of scale, a lot of data. And in those situations, right, Federation works really well with materialized views. So you can go ahead, create a materialized view on a schedule with a trigger, however you want to name it, which will give you consistent latencies and concurrency regardless of how much data you're pulling, because you'll at that point be working on top of Delta, and will smartly manage and make sure that we refresh it for you and we handle reliability on those refreshes so you don't have to worry about it. And a lot of customers I talk to love this when they're especially doing large cross-source joins or complicated transformation logic, where they don't want to necessarily hit an operational system they might have, or it's just, again, due to the sheer size of it, it might be practical to get that done. And so how are customers using this stuff? In a lot of cases, right, query federation is one of the first kind of things that customers start off of it in their environment, because again, without having to invest into ETL pipeline, without having to invest into these different things, you can actually get going on the discovery, registering your external data sources, and all of a sudden, all of your Azure, AWS, Google ecosystem data sources are available in your environment as metadata, which you can directly query, directly access, directly govern. And that is powerful, right? Because you get all the, as I was saying, you get all the capabilities of Unity Catalog in terms of, hey, who's using this? What are the most frequent joins? What are the most, top tables, top users, all of that stuff. You can govern it. And when you want to actually productionize it, you have many options, right? And when I say productionize, I'm talking about, let's say you have a latency sensitive application, or you have like a, 1,000 concurrency use case, right? We will let you also do that by giving you either materialized views, giving you CDC pipelines with the new announcements you're going to hear on the ingest side, or just letting you build pipelines on top of these things directly from SQL, which is, again, a very easy to use, powerful way of just dealing with these things. So it really helps you kind of get into this discover, query, govern, productionize, and then repeat without having to do a lot of the work you would historically do upfront. You can kind of put that later in your pipeline so that you're getting to insight faster without having to do all of this ETL. But again, federation really works well with ETL. You just need to kind of figure out what the transition points are and when you want to do which one, depending on your use case. And this is just one of our examples of our internal pipelines, by the way, that uses federation, which is pulling a lot of these different kind of things into one of our monitoring, alerting APIs, and then kind of using that downstream. So we're not only seeing this with customers, but our internal customers are, our data team, our like other engineering teams are already using it as part of that too. And as you heard earlier today, right, we're actually announcing general availability of a lot of these new features. Most of the things that we've been working on in the last year was around making sure that you get top-notch performance across MySQL, Postgres, SQL Server, Snowflake, Redshift, Synapse, and BigQuery. We've also enhanced a lot of the security primitives that we offer with these connectors, right? So now on all the Azure ecosystem connectors, you have Azure AD connectivity, and on the Snowflake side, you have auth. And you'll see us add more sources as we go along too. So we're also announcing the preview of the BigQuery connector and then the Salesforce Data Cloud connector. And when you put all of these things, right, we already believe that you can get a lot of your work done, as you're kind of onboarding yourself to understanding how this could be working in your environment. On the performance side, one thing I want to mention is we've not only improved push-down coverage and performance across these sources we listed here, but we've also made it much easier for folks to understand what's happening behind the scenes. So now when you go to a query profile of a federated query, for each of the different sources in your query, we'll show you what you're pushing down exactly in the dialect of that source system. We'll show you how much time it took, how much rows you returned, and all of those things right in there. And on the security side, as I told you, right, this is a big issue for us, and we want to make sure that for each of the sources that we support, you get whatever option for authentication you have in your environment. So a lot of focus on Azure AD, a lot of focus on Snowflake auth, and you'll see us also release the AWS ecosystem IAM role support quickly as we finalize our efforts on this. And just looking ahead, just to give you a few more exciting things to think about as we think about these things from a roadmap perspective. One thing that really excites is us making sure that you get faster data transfers between these data sources, and that happens transparently to you. So one thing that we're working on right now is high throughput data transfer. And how this is going to work is that we're basically, starting with Snowflake and Redshift, we're basically going to, on your behalf, use the Unload APIs behind the scenes, automatically provision a UC volume, which is basically an object storage location managed by UC behind the scenes for it, transfer it there in your account, read everything in parallel. So as opposed to going through a single JDBC or DBC driver pipe, basically, you get this high throughput transfer where you're going to get much easier and simpler access to larger tables. So you can ingest them, access them, materialize them, do whatever you want with them. And that will all work without you having to set anything up behind the scenes after you set your initial Lakehouse Federation connector. And more connectors is always something we're excited about. Right? So on top of all the, improving the existing connectors, after GA, you'll actually see us kind of switch gears a bit more and have a more balanced approach on new connectors and new features. So far, mostly it has been making sure that we give you a great experience on the existing connectivity. But as we ramp up post-GA, you'll see us do a lot more in terms of new connectivity. So the two that are going to be very immediate are going to be the BigQuery connector and the Salesforce connector, which is going to be quick follow-ups to GA. These are both already in preview. After that, the teams are working on Teradata and Oracle, which is actually on our top of our list in terms of customer requests. And then each quarter, you'll basically see us announce the next quarter's connectivity and more. So this is going to be something ongoing. And we're not picking these data sources just randomly, right? They're really based on the customer demand and customer usage we're doing. So as we see asks, usage, and just demand for this, you'll see us prioritize all of that. And one last thing that we already announced earlier is this is all going to work with Delta sharing. So you are going to be able to Delta share all your Lakehouse Federation data sources out of Databricks if you wanted to, using the sharing for Lakehouse Federation capability. And that's going to, again, work transparently without you having to do anything else, given that you have set up your connections and for catalogs in Databricks. And now I want to hand it off to Todd Greenstein to cover the catalog federation side and all the exciting updates there.
Thank you. All right. So we took this really exciting framework that we've already built, which John's team has graciously put into GA now, and we're basically building HMS Federation on top of this. And this gives you, again, transparency, just the key word here, transparent access to all of your data. If that exists in a legacy Hive metastore that's in a Databricks workspace, if it's in an external Hive metastore that you still have other things that need to continue connecting to that, we will support that as well. Or even if you're using AWS Glue. So this really gives you kind of a best of breed way of having transparent access to all of these sources. Why did we do this? So we had Lakehouse Federation already, and we thought, hey, this is the perfect framework to actually give us this access to our legacy metastores. And this really reduces friction for onboarding to Unity. And in addition to that, this really improves the migration process. So if you're thinking about migrating off of your existing Hive metastore and into Unity catalog, this is the preferred way that you can get access to that during that time and give you kind of just a really immediate access to that data and where it lives today. And also, we also didn't want to just stop there. We wanted to limit, or we didn't want to limit any of the access there. We wanted to basically provide transparent access to, if you have an existing metastore like AWS Glue that you need to continue to access from external clients outside of Databricks that would connect through Glue. We wanted to make sure that you have transparent access to that, and then also that same access is available inside of Unity Catalog as a foreign catalog. And let's go to the next slide here. How does it work? So we already have this Lakehouse Federation framework, which we've talked about. And it's very easy to set up a new connection object. And in a moment, you'll see how Andrew kind of walks through this process. And when you set up a new connection object, we scan for metadata. We basically mount the catalog as a foreign catalog in UC, and then you get full access to your data there. And the thing that we're doing that's kind of unique for Lakehouse Federation that we don't see anywhere else kind of in the market is we give you just-in-time metadata updates. So you never can access stale data. And what I mean by that is every query, within the scope of that query, we make sure that we update the metadata for that particular objects within the query, and then you're never accessing stale data. So that's kind of a really nice safety valve to ensure that you are always getting the current data snapshot or the current data picture on foreign sources. And let's look at a use case here really quickly, and I can just kind of walk through this. For Unity Catalog, once you set up your the connection object to connect to a legacy metastore, you basically have full access to that data. And we go through and we crawl that data. We mount that as a foreign catalog within UC. Then you need to have access to the storage underneath. And the way that we do that is we have tooling that kind of helps you and walks you through this, that basically helps you create storage locations that are just like you would access for every other catalog in Unity. And you can do this for DBFS, which is coming, it's not quite there yet, as well as S3, ADLS, or GCS sources. And now your basically access is basically transparent, and it's the same for every other catalog in Unity. And this makes it really easy for you to start transferring jobs over and do things around basically transparent access if you continue to need that for external sources. And for multiple workspaces, now we'll basically, with Unity Catalog, you would basically have access to this from any of your workspaces. So this isn't workspace confined any longer. And we'll talk about our demo here, what we're gonna do. This is the most exciting part.
Audio. Okay, thank you. Just to kind of level set right before the demo, because we actually have a demo that's going to cover multiple things. I just want to give you guys a quick, part by part analysis, rundown of what we're going to talk about. So we're going to be going over a campaign analytics data set, which is basically spread across multiple, data sources, which Andrew's going to cover. But overall, we really want to kind of nail down on the setup experience, on how these things are set up and managed, how we're integrating all of these capabilities natively into Unity Catalog, and how these things basically work just like any other internal Delta table in Unity Catalog, and how that basically enhances the experience. How we can consume all of this stuff, whether you're using SQL, whether you're using AI BI dashboards, AI BI Genie spaces, all of this is hooked up already, or whether you're using an external BI tool, and how you're going to administer them. And then finally, we just wanted to show you a few things about Catalog Federation, how that really simplifies migrating things over to Unity Catalog, or just giving you access on your Hive and Glue environments. Thank you. And now we want to have Andrew in the stage. Thank you, Andrew.
Hey everyone, I'm Andrew Lee, and I'm the lead developer on the Lakehouse Federation team. So I'm very excited for this demo time to show you how we build this feature and we envision it will work for our customers. So let me quickly go to the Databricks workspace. So this is a real world scenario where I'm going to try to illustrate is, imagine there's a Databricks team who is doing marketing campaign analysis. We have a global team. We have people in the US, Japan, France doing marketing analysis, but unfortunately, our teams don't use the same software. Some people use Snowflake, some people use SQL Server to store their data, some people use BigQuery, and then my boss asked me, I need to do data analysis, but if I can't bring the data together, how do I make the analysis? So Lakehouse Federation is a tool that helps you to achieve that. So in order to do that, it's really simple. You go to this connection page in the Databricks workspace, it's under the Catalog Explorer, and you see how I already created a bunch of connections, but just to show you how easy it is to connect to your data sources, I'm going to illustrate. So first is, let's say I have a SQL server I want to connect to it. It's really just 4 fields: hostname, port, username, and password. I put in all of them, and I click connect. Boom, now I have a SQL Server connection, right? And you say, I don't want to give my password to Databricks. My boss would be angry with me if I do that. What I'm going to do is, for Snowflake, we can use OAuth, right? This is more secure than using a password. And I'm going to put in my hostname, port, username, my OAuth client ID, client secret, and my OAuth scope is using my federation role. I'm just going to click on connect with Snowflake. And when I do that, I have my username, password, I log into Snowflake, and I'm just going to sign in, and I'm going to authorize Snowflake access to my connection, and I can now just click create. Okay, great. Now I have a Snowflake connection using OAuth. So as you see, it's really easy to connect your data sources, but what does this mean for me as a data analyst? So if we go to the Catalog Explorer, you can actually see that I have already created a bunch of catalogs. I have Hive catalog, a Redshift catalog, I have Snowflake, SQL Server, and BigQuery, right? These are the data that my marketing team across the globe has collected for me to make analysis on. As the key thing about Lakehouse Federation is it abstracts away my understanding of these systems so that they all show up in Unity Catalog as a single, unified abstraction, which is a catalog, and all the UC features I'm going to show you that you love, and for UC, normal UC catalogs, we work with these foreign catalogs as well as. So let me actually zoom in, and let's say I'm going to navigate my SQL Server data. I'm going to click on it, and you can see all my SQL Server databases. I'm going to my DBO schema, I'm click on my user data table. And you can see that this thing works the same as other Unity catalog tables. I have my AI generated suggestion about a table, SQL Server doesn't have that functionality. I have all my schemas, and you can actually see that I can actually do all the UC features, right? So for example, I can go to the sample data, and I can see all my data that's from SQL Server. This data is not being moved to Databricks, still stays in your SQL Server. I'm just querying it in real time. Everything happens in real time. Like Todd said, there's no stale data. Everything is fetched in real time. It's actually really fast too. SQL Server is fast. And you can also give permissions to your table. You can go to the permission tab, like Jen has select permission on this table, same old unical permission. But if I want something more fancy than that, I can actually go to this tab, and I can actually say like the first name, last name. I don't really want them to show up to my clients, like they are PII data, and I have regulations. Let's say this is team in Europe. I cannot actually give my data to the US people due to GDPR. I'm actually going to mask this using a column mask, and I'm going to use this username mask, and it's going to change all of the username to redacted. So now I'm going to add this, and now I have this column mask, and if I go to sample data again, and refresh this page, again, it's going to fetch data from SQL Server and redact the last name. So you now can see that the last name is also redacted. So also, Unity Catalog gives you this nice feature of giving you like overview of who is using this table. Like you can see that there are many people doing SQL queries, like some people creating tables out of it, some people like doing notebook analysis, and if they have notebook dashboard, they will show up here as well. So when people run these queries to create tables out of your SQL Server data, they actually generate lineage. And the lineage is actually also supported for these foreign tables. So you can see in the lineage tab, I have this SQL Server table I just created. And since my boss asked me to do analysis based on the global campaign data, I'm creating this aggregated campaign table. And if we can click on this little add button, it's actually going to show me where this data comes from. And it's going to show me that this data actually is created from one SQL Server table, one BigQuery, one Snowflake table, one BigQuery table, one BigQuery table, and one Hive table. So like I joined all these 5 together using inner join, and I get this aggregated table. So this table will be stored in Databricks as the Delta table. So that means like all the features that work for Delta will also work for this table that I used inner join to aggregate on. So if I click on expand and see the downstream things that I generated from it, you can see that I could build a materialized view as a cache of this data in Databricks, so I can build snappy dashboards, like they will hit the cache and it will be really fast. I can also refresh it using the source data, like Jen just said. And I also built a machine learning model. This is where Databricks really shine. Like we have so many AI functionalities as machine learning features, ML flow, experiments, model serving. You can really just use them on your SQL Server data, on Snowflake data, on your BigQuery data. Like even if these vendors don't provide the functionalities, you can use them in Databricks and unlock AI's potentials. Like in this case, I'm trying to predict how much money I'm spending for each user that clicks on my web ads, right? So I can do prediction on how much cost I'm generating for these ads campaigns. Okay, so now we have done like the basics of a foreign catalog. So what can I do now? Like my boss asked me that, Andrew, can you go generate a dashboard for me to understand, let's say, how much money I'm spending per country on these campaigns? Sure, like I will just go to the AI BI dashboard, and you can see I have already built some dashboards based on this data. I know like how much, I was talking about cost per click, is like how much money I'm spending per click, and you can see that there's different distribution for different types of ads. Right? For example, for display ads, they are pretty expensive, and for the video ads, they're actually cheaper than display ads. And you can see like the search ads actually a wider variety. Like sometimes it costs a lot, sometimes it costs very little. And I can also see how much money I'm spending per country campaign. I spend the most of my money in the UK, which is like 250K, and spend the second in the US is like 200K, right? So and I have different countries as well. And now my boss asked me, hey, Andrew, this is great. You build these dashboards, but now I have a different question. Your dashboard doesn't tell me that. And I need to go ask the data myself what's the answer to my questions, but I don't know how to write SQL. I haven't written SQL in 10 years. How do I do that? So turns out like Databricks has a nice feature called Genie, it's called AI BI Genie, that allows your boss to just come in and ask questions on your data, the data that you just did a 5-way inner join and moved into Databricks. You can actually say like, what's the lowest, for example, this question I already have, is that what is the lowest cost per click region for video advertising? It's actually a really complex question. It's like there's a condition that it has to be video advertising, and it's like what is the lowest region in terms of cost per click? So you need to do aggregation on cost per click. So but you see that it can actually answer really well. It tells me that in the country of USA, I'm actually getting the lowest cost per click. And how did it do that? So if you look at the generated code, you can actually see that this thing is doing a select country code, and it's doing a min aggregation on the cost per click column. Again, like the AI just like takes all the metadata from Unity catalog. Remember, like we have all the schema metadata that we pulled from data sources, so it knows which column it should use for your question. So in this case, the cost per click column is the one that should be using, and it's selecting from this aggregated table which is generated using joins, and it's smart enough to tell me that, oh, Andrew only wants video type like advertising. So it's doing a where condition, it's doing a group by, and it's going to order by the mean cost and only give me one result. So this is really great. So I can also ask other random questions like, what is the ROI of my campaigns by country? And you can see that it's syncing, and it's going to actually fetch the data. Yeah, and it's going to give me the explanation. It's going to run the generated query. In this case, it's generating query that's giving me the like per country cost, and the ROI is actually using a divide, which is the amount I won for each opportunity divided by the cost, which is also very smart. It knows how to do that. Okay, so now we are done with consumption, but let's say that, okay, how does this work? How did you do the join, right? It's like for the analysts, like how do we actually use these tables? So now I'm going back to the inner guts of how this works, right? In this case, the aggregated table is just like a 5-way inner join from these 5 tables. So you can see that I'm actually using these tables like a snowflake table, exactly the same as if I'm using a Unity catalog table. So it's basically like snowflake advertising.marketing.web events, and BigQuery table and SQL Server table is like SQL Server catalog.dbo.user data. I'm joining it with BigQuery advertising.advertising.adstats, and I'm joining the Hive table. So you can see like all of these are unified under Unity catalog using the foreign catalog the same way you can use them in any SQL query, pretty much any SQL query, the same way you use with the Unity catalog table. And the only syntax you need to know is Databricks SQL. So under the hood, what happens is if I go to the query history, I already ran this query once, you can see this more complex view. Like, probably only like nerds need to know this, but I assume you're all nerds. So, so bear with me. So you have a snowflake join with a BigQuery table, with a SQL Server table, with a Hive table, with a BigQuery table. So you see like it's like all aggregated together to this single tree, and then it's the final result you got. And the cool thing here is actually you can click on one of these nodes. In this case, is the BigQuery query. You can see the federated system query that we generated out of your commands, right? You're asking for sums on clicks and cost macros in your query. They are pushed down into the target system so that we only fetch the minimum number of data rows. And also it will basically minimize the cost to the local filtering and local aggregation in Databricks. So in this case, the query actually runs really fast. It only runs 200 milliseconds and returns 124 rows. And you might actually have something like more like that takes longer time. For example, in this SQL Server query, I'm like taking like more time, 400 milliseconds, and returning 100K rows. But yeah, you basically, because this one is less filtered, it's just a select star from the table. So like you get all the insights into things that are working and things that are not working, and you can debug them, like see why sometimes it's returning more than I want and it's taking more time I want. And you can see that because this SQL Server query is taking more rows, so it's actually the one that takes the most time to generate. It's like this like dark color thing that's it's telling me like this node, this aggregation is taking the most time in this query, the majority of the time. Okay, so now we are done with the administration part. So what about the data engineering team, right? The data engineering team will always do all these pipelines, take some table, plumb it into somewhere else. So let me actually go show you this. This is the Hive Metastore. And we have all these exciting UC features, but the Hive Metastore users are actually left behind, right? If you go to Hive Metastore table, you look at linear sys, go upgrade to Unity catalog, you go to permissions, give you this nasty arrow, you go to the insights, go upgrade to Unity catalog. So, okay, I can use anything with this Hive Metastore table. Anything that is developed in Unity catalog in the last 2 years cannot use them. So how do we solve this problem? Like Todd said, we have this federation tool already, and why don't we just use federation to federate the Hive metastore into Unity Catalog, and then all your table metadata will be copied into Unity Catalog, and all the cool features will just work. So the way that works is I create this federated catalog called Hive product campaign that's mirroring my Hive metastore. And I'm a data engineering team. I have this legacy ETL job that's targeting the campaigns table in the Hive metastore. I'm taking the campaign table, it's just a bunch of like each campaign data. I'm doing sum and average aggregations on it, and I'm getting this aggregated table based on like the summary of my cost and the average cost per click, right? Very simple ETL pipeline. So this thing works for Hive metastore. But the only thing I need to do now with the federated catalog to migrate this thing to Unity Catalog is just to change this to Hive product campaign. This is the only thing I need to change. And I can just run this whole pipeline, and it's going to run the same way as it was in Hive metastore. Like everything still works. Like I create a table, I get the summary table, okay, everything works. But now the difference is I can finally go to the Unity Catalog, and I can now look at the Hive product campaign catalog, and now you see that I have the campaigns table, and I have the summary table that's aggregation of the campaigns table I just generated. And you can see that all the UC features start working. I go to lineage, it's working. I go to insights, you have permissions, you can give UC permissions. So now your Hive tables are fully UC capable. So I can go to lineage, and I can look at the lineage graph. You can see the table lineage where I just run this ETL pipeline. I take the campaigns table, I did some aggregation, and I moved it to the Unity, the same Hive federated catalog, which is called campaign summary. And then I'm also getting column level lineage, right? So all the summaries, I can see that how they are generated from the source. Okay, so we have talked about federation. We have talked about how to consume the federated data. We have talked about like how to get insights into your queries. We have talked about how Hive federation works and how it makes migration to Unity Catalog and transforming your ETL jobs to be Unity Catalog compatible really easy. So like one last thing I want to mention is that now that you have like the bidirectional sync between your Hive catalog and your Hive metastore, like Todd said, the key thing here is actually the transparent access, right? So imagine if you have other data vendors that are consuming Hive metastore from outside of Databricks using Trino or Spark, open source Spark, they can continue to access the new tables that you generate within Unity Catalog, because those new tables will also be reflected back to the Hive metastore when you are using the federated catalog within Databricks. So it's really about like using federation. You not only have one-way sync from your Hive metastore to Unity Catalog, which is probably most people are doing today for UC migration, they just copy data over, but you also get your new things back to your Hive metastore so your external clients can continue to consume them. All right, that's all of my demo, and thanks everyone.